Well, g'day, Max here again, welcome back to the shop. So this is going to be part 2 in the short series of the GTWR indicator holder series. So today we're going to make a start on the curved arm that will hold the indicator. So there's a couple of different methods that we can use to produce this part. And watching, well, there is already a few other people starting this same project, so it'll be an interesting project to watch how other people do it, because there'll be a lot of different methods employed to make the parts, but we'll all have the same outcome in the end. It's just a lot of different methods depending on what tools and bits and pieces that others have to make the same part. So anyway, we'll have a look at the drawing and we'll tell you how we're going to make this part. Okay, our original plan was to make this out of a piece of solid round bar. Now I did have a piece of 304 stainless, but unfortunately it's not quite big enough in the OD to match up to these radiuses. And I've got this piece of mild here, but that's a bit boring. I want to go for something a bit more exotic than that. But to do it the round bar method, I feel, is the easiest way, as you could just set this up, well, once you'd had it in a lathe and machined the ID and the OD to match the radiuses here, you could set this up on the rotary table in the mill. It's all the information is on the drawing here. You've got 150.33 degrees as your arc for your centres. You've got a 7.68 offset from your centre of your diameters or your radii to the a line drawn across where the holes are. So they're easy offsets to do on a rotary table. So then you've immediately got your positions for your two holes. And while it's in the mill, after you've done the holes, you can rough the radiuses here to size just by walking an end mill around. Just make them, don't quite go up to a scribe line, just keep a little bit away from it. So that's dead easy. So then we take this back to the lathe, we part it off, so we have this part here, and then this will be a scrap part which comes off. So then we put this back in the rotary table. We put a dowel pin in our hole, and then the part that we're making, we slip over the dowel pin, and we can put a little end mill in, and we can walk this piece around by hand, pivoting on the dowel pin, and that'll neatly trim that radius up exactly spot on. Now, if you pay a lot of attention to getting these radii here absolutely spot on, everything will match up nicely. But that's, unfortunately, we're going to go a different method. But, we'll swing you around and show you that. So we have this piece of aluminium bronze. It's pretty tough stuff to machine, this stuff. This is an old thrust washer out of a machine. So all we're going to do is skim both sides of it, just to take, because there's a wear. It's worn, it's not even, this face, as it's an old thrust washer. So we'll skim it true both sides, and that'll give us a good flat piece of material to work with, and it'll allow us, because this is 1/4 inch thick, so we've got to take it to 6mm thickness as per the drawing. Oh, that's cleaned up nice. Yep, no, that'll be fine. That'll be really good. Okay, so that's all the lathe work done for this part. So all the rest will be in the rotary table in the mill. We have our aluminium bronze ring pretty well securely clamped down onto the rotary table there, and we've swept the rotary table and lined it up with the quill. So we're right on centre of the axis of the machine. So what the plan is now is we'll put a cutter in and we'll move the table. All our movements will be on the table, and we'll just step across to do our first radius, step across to do our second radius, and then we've got the PCD for the 2 holes in the middle. Okay, we're just laying out our radiuses just so we don't have a bozo moment. Okay, so our first one is 25mm and 30 to the centre and 35 to the outside. We'll start off getting our 2 holes drilled in this plate first before we start chopping it out. That way it gives it maximum support. So I just have an indicator set up on to monitor the table travel as well, and that helps me maintain the 0 position off the dial, just to take up the backlash, because now I've got to start winding the other way. So it's just compensated for the backlash, and I can reset the 0 on here. Knowing full well the table hasn't, I can bring it back to the true spot there. So we've got to go 30mm. So that's 5, 10, 15, 20, 25. So 30mm. Bring it down, we'll check it against our anti-bozo lines. And we're right on the money. So what we've got to do now is rotate the rotary table till our first hole lines up. So we're going to move the rotary table around 75 degrees, 9 minutes 36 seconds. That gives us our first hole location, because we're on the centre there. So, what was it? 75 degrees, 9 minutes 36 seconds. Okay, so .75 degrees, 9 minutes 36 seconds, which is there. Okay, that's our first hole location. Now, before we drill too deep, I'm just going to scribe the end circle radius around. Just lower the table. This will just help us when we start freehanding in the radius. A bit tricky. Nah. Just a guideline. Okay. We'll put our pilot hole in. Now, this is supposed to be a reamed hole because it's a pretty close tolerance hole. Now my reamer, I do have one ordered, but she's still in the post. So there's a couple of tricks you can do to a drill bit if you haven't got a reamer. You just very gingerly just grind off the very corners, just radius the tips of the corner of the cutting edge there. And then I've just cleaned up down the side with an oil stone just to reduce it a little bit. And I did a test hole just here, and we're drilling just under 5mm. So it should be good. The spec for the hole is minus nothing plus 0.012. We're better off on the tight side than going over the 0.012. So okay, that's it. So yeah, that gives us a nice tight fitting hole, that. So if the reamer does turn up in the post, I can always run it through, but I don't think we're going to need it. Okay, so we'll spin around now and we'll get the other hole location. Okay, we've moved the rotary table round to the second location. We'll just do another anti-bozo check, and of course the clamp's in the way, and we're looking good there. So that measurement there was 60.5, so I've measured from the outer edge of the hole to our centre position. So 58 plus half the hole is, yeah, 60.5. So we're looking good there, so we can confidently drill that and know we're in the right spot. Supposed to be a steering wheel coming in the post for this mill, courtesy of a kind gentleman over in the States. Would be really good for these sorts of jobs rather than this little Bridgeport handle. You know, I think it's a lot more sensitive with a steering wheel for close-up sort of work. Okay, this is our drill reamer. Hole number 2. It's just taking a few thou out. Okay, we're looking good. Okay, so we'll swap over now to an end mill. We'll start cutting the shape out. Before we start chopping the parts out, let's just give this thing a little bit of bling. I think the bling it deserves. So we'll just put a bit of a radius recess through the centre of the part. There, gives it a bit of bling. Okay, so we've got an end mill in now, carbide end mill. So now we can start chopping out this area here and coming up to our scribe line. Okay, so we've got our vernier set on 50mm. It's a bit of a struggle to get in to check this. And that's there, the corners are just going in. I could check it with a mic and telescopic gauge, but for this it's not required. So we're spot on size there. So now we'll do the external radius, the same process. Okay, as you can see, we've flipped our disc over so we can do the groove, the bling groove on the other side. So we've re-centralised the part. And that's close enough for what this thing does, so we'll get the ball end mill in and cut our groove. I've also jammed a adjustable parallel under there, because we've cut so much of this away just to give it a bit of support. Okay, that looks good. So all we've got left now is to do the end radiuses and some deburring. So our last machining operation is just to touch up these end radiuses. Now you could, if you're not used to working with close proximity to, sharp cutters, rotating parts, I'd probably recommend you do this with a set of filing buttons instead of this method, but this is the method that I'm going to use. So I've just turned down a little spigot, 5mm spigot, which our part will sit on, and then we'll just slowly bring it up to the cutter and just slowly walk it round by hand. Okay, we'll just touch up the intersections with a file. It should be good. So to file a radius properly, that's not really the way you want to do it, around that way. You've got to go opposite the radius, and that'll give you a nice blend line. Okay, so I'll just use a finer file now to this file is that fine I could hardly feel the teeth on it. Just keep working it opposite direction to the radius. That's the correct way to file a radius. Pretty hard to get this all on camera, me blimmin' hands in the way. So yeah, we've got a nice blend, blends in very nice there now. So now to touch up this little point here, I don't want to use a file on that, so I'm just going to use a piece of round bar offcut and a piece of 180 emery. And just slowly work that transition point in. And then we can finish it off. I've got a piece of 800 wet and dry. Okay. So that's brought all our radiuses in. So we'll go over to the buffing wheel and just give it a bit of a shine. Okay, so after a quick polish up, I think it's come up quite well. It'll do for what it's got to do. So we've got to start making some of these parts now. So we'll get a bit of material chucked up, and that'll be the next video. Yeah, so those parts come up quite well. So the next thing we're going to tackle, I'd say it's probably going to be the DTI holder. Now that has that miniature dovetail in it. Now I've never cut a dovetail that small in my life, so that won't be without its challenges. So if we're going to make a pig's ass of anything, you can guarantee it'll be that dovetail. So we'll see what happens. So stay tuned, take care, hopefully we'll see you in the next episode.